Hey there, SAT review students. This is Mr. Chu, and I am ready to do another video of SAT review problems with you. So there's 3 on this one. So let's get to it. So this is video 8 of my module 4. I've got module 1, 2, and 3 already on the computer. There are 27 problems in each of those modules. The videos have 2 to 4 problems on each of them where you can just go through one at a time. After you subscribe my YouTube channel and go to my playlist, click on them, and then review for this important test. All these problems come from the College Board's release in modules of problems with 27 on each module. I am almost done with the 4th one. I've got 3 more problems to do after this, and then I will have all 4 of those done. And there are 2 more for a total of 6. So these particular problems, some of them are going to be easy for you. Some may be a little harder. They deal with algebra, geometry, and could be any other of the math topics that you take in high school up to the point when you'd be taking the SAT. And the topics vary. I do not group them based on the topics. They're listed in the order that they're put in the modules. Like this video if it's helpful. Follow me on TikTok, Instagram, Facebook, and X. I got lots of math videos. I got puppy videos. And I also have announcements of things that are coming. I do have this YouTube channel that you can subscribe to. Here's the long link. It's YouTube at mr.keithychew.com. There are various places that you can click to subscribe, or you can put that in a browser to go to my channel. And then the reason you subscribe is so they'll come up easier and faster. And it helps me out too. I do have an email address that I'm pointing to right now, askmrchew@gmail.com, if you have any questions or requests of particular videos. All right, so the way this is designed, we got 3 problems here. Pause it after you understand what the problem is, work it on a piece of paper, then start the video back up again. Then see if you have worked it correctly, and if not, you can correct it as I work it. So number 22, it's about the area of a right triangle. And the problem with it, what makes it hard is that the lengths have radicals in all 3 of them. So you have to remember the area of a triangle. A equals 1/2 BH. You got to figure out which is the B and which is the H. Well, I'll give you a hint. They are the legs, which means the 2 shortest sides. So pause it now, work that out, and then once you start it back up, I will be happy to work it for you. So I gave you that area formula. 1/2 base times height is the area. B is the base, H is the height, and those 2 are the legs. So the 2 legs are the base and the height. That means that you need to determine which one is the hypotenuse. So I'm going to find the approximate length of each side. So I've got one length, which is 2 square root of 2. So on a calculator, rounded to the nearest hundredth would be 2.82. And then we'll do our 6 square root of 2. You know it's bigger than that. That's 8.49. But now we don't know about the 80. We know it's between 8 and 9. And it ends up being closer to 9. So that square root of 80 is your hypotenuse, which means that the 2 square root of 2 and 6 square root of 2 are the 2 legs. And it doesn't matter which one you say is the base and which one you say is the height, because they intersect at a right angle anyway. And that is the definition of the height. And since multiplication is commutative, it doesn't matter if you multiply 2 times 3 or 3 times 2. You're going to get 6 either way. So I just said, let's say the base is 2 square root of 2, and let's say the height is 6 square root of 2. And then I use the substitution property of equality. where I put for the b 2 square root of 2, I put for the h 6 square root of 2, and now I'm just going to go through and take and put the numbers side by side and the radicals side by side using that community property of multiplication. Okay? All right. So now I'm going to take the 2 and write it as 2 over 1, because that is 2. And you know that these are going to cancel and I get 1 here. So I get 1 times 6, and then times square root of 2 times square root of 2. Now I'm going to take my 1 times my 6, and that gives me 6. And then I got square root of 2 times square root of 2. So there is a property of radicals that says if you're multiplying two radicals, then you can put them under the same radical sign. And so 6 times the square root of 2 times 2, which is square root of 4. And most people know the square root of 4 is 2. 6 times 2 is 12. So the correct answer is B. Hopefully you were able to get that. Now we'll go to number 23. You can see all these problems are a lot different. None of them are exactly the same. So I've got an expression which is a quadratic, 4x squared plus bx minus 45. And the problem is I don't know what b is. But it says b is a constant, so it's a number. So it can be written as, this whole quadratic can be written as the product of two binomials. And that would be like if you were factoring it, where h, k, and j are integer constants. So h, j, and k are going to be integer constants. Which of the following must be an integer? So it's asking which one of these. So what you have to do is you have to take and multiply these by using FOIL, and then solve for, since we've got h here, you're solving either for k or j. So let's just go through that, pause it and work it out and try it yourself, and then I'll work it for you after you start the video back up. So it's given our quadratic, and we're saying that you can write it like this, which is a binomial times a binomial. Let's use FOIL to multiply that. You remember how you use FOIL? You take your first, you take your outer and multiply them. You take your inner and multiply them. And the last, and it's FOIL. Now you're saying, yeah, but what is that? Well, I'll go through each one now. So your first hx times x is hx squared. Hx times j is jhx. K times x is kx. And k times j is kj. Okay, so now I'm going to factor a GCF out of these two middle ones. Well, how do I know to do the middle ones? Because that's where that middle one is in that B. So I'm going to have to do something with that B there. So I just put parentheses around there and I say, what do they have in common? Well, you can see they both have an x. So I can reverse the distributive property by factoring that x out, and x times jh is jhx, and x times k is kx. Ah, there that is. So now look, see how that's 4x squared plus bx minus 45? And the b is going to be this number in the parentheses. And my kj is going to be negative 45. So I know my b is in parentheses, and I know the kj is negative 45, and you know that these have k, h, and k in there. Okay, so if kj equals negative 45, Now I can solve that using the division property of equality and solve it for j and see how I divide both sides by k. And when I simplify that, I know that if j is an integer, then I know that this number has to be an integer. And if negative 45 over k is an integer, that also would mean that positive 45 over k would be an integer. It's a little bit tricky, which is D. All right. Now we'll go to the last one in this video. And in this problem set, I'll move my picture up here to be out of the way because I've got lots that I have to write on here and here to explain this because this isn't really easy. In the given system of equations, so I have two equations that are a system here. A is a constant. You see how the number's missing here and it's a constant, okay? The graphs of the equations in the given system intersect at exactly one point. So this is a quadratic, so it's going to be a U-shaped. This would be a straight line, and they intersect in one point. All right? So the top one is a parabola, and this one's a line. What's the value of x? Well, if this top one intersects in just one point, I can use something that you learned in algebra called the discriminant. But first, I need to subtract these and see if when I subtract them for that solution, I can still get a quadratic and use that discriminant for that location. So here's my first equation. Here's my second one. There's two ways you can solve this. Either you can use substitution or you can subtract the two. I'm subtracting them because I'm going to get a 0 here equals something, and we can solve for the roots when that happens. If you substitute here, you're going to get a kind of a complicated algebra mess, but you could try that if you wanted to. I'm just going to take and subtract a y from a y and get a 0. And then I'm going to subtract a 3x from a minus 21x and get a minus 24x, and subtract an a from a 64 and get 64 minus a. Okay, so all I did was subtract each of these. There wasn't anything that subtracted from this. I subtracted 3x from a negative 21x to get negative 24x, subtract an a from a 64 to get 64 minus a. All right, so this becomes my a. This becomes my B, and then this whole quantity here becomes my C. And I can use the discriminant. Now, what's a discriminant do for a quadratic? It tells you how many roots that has. So if it equals 0, you know it's going to have just one root. So the C ends up being the 64 minus A. The B ends up being a negative 24. And the A ends up being 2. And the discriminant's formula is B squared minus 4AC. Okay? So now I list down here what they are. And then 64 minus A can be written as negative A plus 64. Usually people will write the variable first. You don't have to. So now I'm just going to use the substitution property of equality. So where there's an A, I put my negative 24. It's not negative 24. That's 2. So that is a mistake. So that's going to be 2 there. B is negative 24 here. Oh, that's because it's B squared here. I was going to say, where did that come from? I thought, oh, everything's messed up, so I'm going to have the wrong one. No, I'm not, because I'm using B squared minus 4AC. So this is a typo here. Who saw that? So thankfully I did it right. I just typed the wrong letter here. And I don't know why I did, but it doesn't matter. Figured it out. I knew something was wrong. So I put my negative 24, I'm going to square that, minus 4AC. I've got my 4. My A is 2. Yep, that's right. And then my C is negative A plus 64. All right. So negative 24 times negative 24 is positive 576. 4 times 2 would be my 8. And now I'm going to use the distributive property here. So the distributive property says that I'm going to take the minus 8 times minus A, and then the minus 8 times 64. So that's what the distributive property means. So negative 8 times negative A is positive 8A, and negative 8 times 64 is minus 512. And now I'm going to combine the 576 and the minus 512 because they are like terms. 576 minus 512 is 64. I subtract a 64 from both sides using the subtraction property of equality. It cancels out here, and I get negative 64 equals 8A. I use the division property of equality. Divide both sides by 8. 8 over 8 cancels. And negative 64 divided by 8 is negative 8. And that equals A. But I'm not quite done yet. Now I got to substitute the negative 8 equals A back into my original to get my number here so that it looks like a regular quadratic. 64 minus 8 would be minus a negative 8 rather would be plus a positive, and 64 plus 8 is 72. But I factored the 2 first. So this is 2 times x squared minus 2 times 12. And this is going to be 32 plus 4, which is my 36. Now this x squared minus 12x plus 36 is a perfect square that can be factored into x minus 6 times x minus 6 in the quantities. So x minus 6 or 0 equals x minus 6 or 0 equals x minus 6, which means it's the same number, which is that one point that it intersects, which would be probably the vertex. So the answer would be C. Hopefully you got that one right as well. So were you 3 for 3? Let me know in the comments if you were. All right. So we're winding down, and I've got just one more video to do, and I haven't started even writing that lesson on it, and then we would be done with that one. Make sure you follow me. I'm on TikTok, and I am Mr. Keith E. Chew, Math Extraordinaire. Facebook, Keith Chew. Instagram, Mr. Keith E. Chew, Math Extraordinaire, and then X the same. I have lots of helpful math videos. I got puppy videos, and I also do updates. I'm going to be starting some Zoom tutoring meetings and sessions for those that's going to need help when the new school year starts. So there's 27 problems in 1, 2, 3, and now I've got 24 in 4. So when I do the next one, I'll have 4 complete modules. Make sure that you subscribe to my YouTube channel. If you haven't done it, do it right now, please. Here's a long link. And there are other links that are available. I do have an email, askmrchew@gmail.com. If you have any math questions or have any requests that you would like for me to do, help me spread the word. Mr. Chew will help students with math questions. I specialize in algebra, and I call my algebra curriculum with videos Bear Algebra. Why do I call it Bear Algebra? Because I've got a 13-year-old peekapoo by the name of Bear. I also have a 3-year-old big 120-pound lug by the name of Brack. His mom is a full-blooded Italian sheepdog called a Maremma. I call my geometry Brack Geometry, and Trey is my 4-year-old black tomcat, and I call my arithmetic and pre-algebra Cray Arithmetic. I do also have something I call Math Minutes. I also have all of these SAT problems. And I also have some new ones I call Mr. Choose Math Minis, which go right along with the Math Minutes. So make sure that you spread the word and let everybody know, all your friends, anyone else you know that struggles, that I'm Mr. Chew and I want to help you in math. I'll see you in the next video. Have a good one.